Hello and welcome to a new tutorial series where I'll be showing how to make a 2D platformer game. There is a YouTube channel called Game Maker's Toolkit that makes really nice, insightful videos, usually into games design. But recently, the guy behind it, has made this little interactive demo for a platforming game. You can find this at this link here on itch.io. I highly recommend downloading this and playing through it, seeing what you think. If you download it, some of the subtleties of the platformer will be easier to access than if you run it in a browser, because there's like latency in a browser, for example, in your input control. And the point of this little essay that this guy has made, Game Maker's Toolkit, is to kind of show how some of the subtleties of how a platformer controls, like for example acceleration and jump height, these things can create a nice feeling platformer. So what I hope to do is sort of extend a little bit the behind the scenes. If you go here to behind the code, you can find the description of a very brief description of how this code is created. So in this tutorial series, I'll be expanding upon some of those ideas and showing you a little more in-depth step-by-step process of developing a platformer like that, with those variables that you can tweak and then also potentially expand with the understanding, hopefully, that these videos bring. The very first thing I've just done here is created a 2D platformer. A 2D project. Just open a new project in Unity and picked 2D. And we're going to need a character to start to move them around. So I'm just going to go and right click on my hierarchy, go to 2D object sprites, and we'll create a square for now. I'm going to rename this our character. So it's just a square. I've created a little art asset for this square to demonstrate just one element of working in 2D in Unity as well that I like to highlight whenever I can. I've created this grayscale square in Piskel, which is a really nice free software just for quickly creating pixel art. Export and downloaded this as an image. So if I go find that image, which I now have on my desktop, I can go ahead and import this into my Unity project. And the key here is that basically, because it's grayscale, if I go ahead and then set my sprite variable of my sprite render to this object, to this asset, I can then change the color of it in this color picker for the sprite renderer. And because it's grayscale, it will be whatever color I set it to, where white will be whatever the color I have, and then darker versions of that same color. So let's say I want a little orange square to be my character. I can just do that. Now it is looking a little blurry, and that's because this art asset doesn't know it's really pixel art yet. It's trying to do some filtering on top of this asset. We're just going to turn off by setting this filter mode to point no filter. And I'm accessing this by clicking on the asset in my project files here. And then I'm going to hit apply. There's our nice crisp art asset. It's also a little small compared to what it was before when it wasn't set to this art asset. And that's because our pixels per unit is incorrect. We've got a 32 by 32 pixel image here, and we want that to span for now 1 unit. So I'm just going to go ahead and say pixels per unit will be 32. And now this will fit the same size that it was before, which is 1 unit of Unity's sort of measuring system, which will now be 32 pixels, which will in turn then be this whole art asset. We're going to go ahead and add a box collider 2D to my character, and we're also going to add a rigid body 2D, and this will help start things off with our character moving, simulating physics. And now if I run the game, they're just going to fall out of the sky, so we're going to need a platform for them to collide with. So I'm going to go ahead and create a new 2D object sprite square again. This time I'm going to drag it down here, stretch it way out, and this can be our platform for now. We'll make it a sort of slightly nicer to look at, darker green. So now our character should hopefully collide with this platform. Oops, I've forgotten to add a collider to it. I don't need the rigid body because it's not going to move around. It's just going to collide with things, unlike our character. So we're just going to make sure that it's got a 2D box collider. And now hopefully our character will actually collide with this platform and not just phase through. So we're going to want our character to move left and right, and to do that we're going to start opening up our code. So I'm going to go ahead and go to my character, I'm going to add component, and I'm going to make a new character mover. I'll call it platformer script or something like that. I'm going to add a new script. This doesn't exist yet, so I'm going to create and add this script. And we're going to want to go ahead and open this up in Visual Studio. To get our character moving left and right, we're going to want to grab input so that we can use, a keyboard, A and D, or a joystick left and right to move our character. This is just taking a while to load in Visual Studio, but here's our script for now. Now our update method is going to happen every frame, so this is where we're going to want to grab our input, because we're going to want to have it be as responsive as possible, so every frame it's going to get a new value for our input. So I make a new variable here, a public variable called float called xMoveInput, and we're going to want to set that in our update, so we can set xMoveInput is equal to input dot get axis, and the axis that we're going to get will be horizontal. If I go ahead and save that, I can go to the preferences, I believe, or maybe it's project settings. Yeah, project settings of our project, and we can see this input manager. We open up this axis. Horizontal is already an input that's sort of set up by default. You can see here it's left and right, as well as this other version of it, which is the x-axis of a joystick. So we're going to want to keep that mostly the same. However, because we're going to handle a lot of the subtleties of our character controller ourselves in code, for example, acceleration, deceleration, we're going to want those to change based on whether we're in the air, whether we're on the ground. A lot of really interesting things going to go on. But that means that I kind of want my input to be as simple as possible and as responsive as possible, because we're going to have that layer in the code. So for the gravity of this situation, as it were, we're going to just set this sensitivity to, like, for example, 10. And we'll set the gravity to 10 as well. And if I go ahead and save this out, hopefully we'll be able to see that represented in our movement values here. So our sensitivity maybe still needs to be a little higher, because as I hold down the D on my keyboard, you can see maybe the frame rate of this video isn't good enough, but the value, instead of going straight from 0 to 1, is actually going sort of along a couple of numbers first. So it takes a few seconds before it gets to 1, and similarly to -1. We want that to happen immediately with our sensitivity. So I'll set the sensitivity to 100, and we'll do the same thing. No, we'll keep our sensitivity at 1 with the controller, because of how the controller works slightly differently. So now if I go ahead and do this, you can see it pretty much changes immediately, because we don't want that layer of sensitivity in the input. We're going to do that acceleration in our code and handle it ourselves. So now that we have our input changing, we're going to want to then actually move the character. But because we're using our physics that is built into Unity to move the character with our rigid body, instead of doing this in update, we're going to make another void fixed update, which is basically the same thing as update. It happens sort of every frame, but instead of having every frame that gets rendered, so like say it's 60 frames per second, this is going to happen 60 times, this update. If physics was calculated in Unity every single frame, it would get a little bit too heavy, and so the frame rate would get worse. So Unity only actually simulates its physics every so often, maybe every 3 or 4 frames. I'm not actually sure how many. And that means that this fixed update is what we're going to want to use for actually moving the character. So we need a reference to our rigid body. So I'm going to go ahead and create a public a rigid body, though I have to make sure that it's a 2D one. And we'll call this uBody for use. The U, just to remind us that we have to set this up in Unity, the reference of the actual variable itself. Now we can access the velocity of this rigid body and just set it to something. But first thing we're going to do is actually grab the velocity. So I'm going to go ahead and make a new velocity here, a vector 2, because we're working in 2D. We're going to call it new velocity. We're going to set the new velocity to be equal to the velocity of the rigid body, and then we're going to set the rigid body to be equal to the velocity variable. Now this basically doesn't do anything, right? Because we make a new variable, we set it to the velocity, and then we set it back again. But in between these two codes of line, we can do something to the velocity. For example, we can set the x value of that velocity to our new movement. And what this is going to do is retain the y value of our velocity, so our up and down. So while we're moving left and right based on our input, we're just moving up and down based on our physics simulation, so i.e. falling. Let's see. Well, we've forgotten to set up our variable, as is want to happen. We're going to go ahead and drag this rigid body in. Now hopefully we will start seeing some movement, though it might be very slow because our x movement value is very low. So we're going to start multiplying it by a couple of things. We're going to want to multiply it by delta time as well as a particular speed. So we're going to go ahead and create a new variable, which will be a public variable, public float called max speed. And we're also going to create a public float called desired x velocity. Now our desired x velocity for the moment is going to be set simply to be equal to our movement speed multiplied by our input multiplied by time.delta time. What this is going to do is take the most we can move, multiply it by the time between frames. Actually, we don't want to do this here because we're going to mix up our updates and our fixed updates. So the time.delta time we want to contain within our fixed update. So we're just going to set this desired velocity equal to our movement multiplied by our speed for now. And for now, we'll just directly input this desired velocity, but you'll see why it's called desired velocity in a moment. So our max speed we can set to, say, for example, 10. And now, hopefully, if we run the game, we'll move 10 times as fast as we were moving before. Though this will also depend on your frame rate, because we haven't made this frame rate independent yet. We could do that down here with times time.delta time. Because we're changing the velocity every fixed frame, we have to make sure to do this delta time down in here. So this is just a 1-for-1 direct. So if I go ahead and change my max speed to 100, I should hopefully go faster, and then maybe I need it actually to be 200. But really what we want to do here is, instead of just moving exactly how much we want to move, we want to accelerate to that point instead, so that we start off moving slowly, and then as we move, we get faster and faster. So if we think of our desired x velocity as the most we can move, instead of just immediately setting our x velocity to that, we're going to instead use this thing called mathf.moveTowards. So mathf is just a static class which can allow us to do a bunch of different mathematical equations that you would expect, like, for example, taking the maximum of two values, taking the minimum of two values, or in this case, we're going to move between two values. So we're going to input two values, an amount, and then it will spit us back a value from the current to the target by the amount. So in this case, the current value is just the one, what it currently is, which is new velocity.x. The thing that we want to move towards, our target, is this desired velocity. And we're going to need a new value for our third one. Let me make this bigger so you can see this a little easier. So our third value as part of this method is going to be our change in speed. So we're going to go ahead and call this max speed change. And the max speed change is basically our acceleration for this frame. So I'm going to make a new float to name it that. We can set it to 0 by default. And then for now, I'm just going to immediately set it equal to our acceleration, which will make us a new public float. So a new public float, this will be our max acceleration. Which will be how fast we move. So now instead of just immediately setting the x value to our desired x velocity, we sort of have to move towards it. So we'll start off with 0 movement change in our velocity, and then it will increase over time. So our max acceleration is going to change how quickly we get to that highest value, and our max speed, our max speed, is going to change how our top speed that we'll eventually get to and then peak out at. Let's go ahead and multiply this by time.delta time while we're here to make sure that this change in acceleration is not dependent on frame rate, but independent of frame rate. We have some values to set because at the moment these are just 0. Our max acceleration, we could set that to 10, as well as our max speed. Maybe we can set this to 100. Let's see what those values look like. So now you can see that because our max acceleration is a fairly low number and our max speed is a fairly high number, it's going to take us a while to get to our max speed. And once we're at our max speed, it takes us a while to change speed as well, because our desired velocity might be going to the left, but we're only going to sort of move towards that new desired velocity via our acceleration. But what if we want something even more subtle than this? We want more control over how this moves. We might want a different max speed of velocity change depending on what direction we're moving or how much we're moving. So we're going to now have, instead of just max acceleration, and I'll actually go ahead and move these all to sort of be in the same place. Our desired velocity is one that we're just going to not set ourselves. So we're going to group these together here. There we go. And our max acceleration we're going to have, as well as that, we'll have max deceleration. I do not know how to spell these things. But that's fine, I'm a programmer. Who needs correct spellings? Max deceleration then, we're going to want to use sometimes instead of our max acceleration for how much we change our velocity. But when do we do one or the other? Well, if we're decelerating, that could be when we're not trying to move, which is to say we're trying to stop moving. And when we stop moving, that's whenever we're stopped inputting something. So if I go ahead and take our input value, which is this x move input, I can create an if statement that asks a question of it. And we can say, is it not equal to 0? Because if it is equal to 0, then that means that we're not wanting to move. I mean, we could do this either way. We could say, is it equal to 0 or is it not equal to 0? Either way, we'll do not equal. So if it's not equal to 0, that means that we are trying to move, which means that we're going to use our acceleration just as normal. But we're going to create a little else for this, which is to say that if we are not moving, or not that we're not moving, but we're not trying to move, which is to say we've stopped inputting left or right, then we're going to use this deceleration value. Now, if these acceleration and deceleration values are the same, then nothing changes, right? We're just doing the same thing we were before. But what we could do here is we could have a higher deceleration value than an acceleration value, which means that whenever we try to move our character, it takes us a while to sort of speed up. But if we just stop moving, our character stops moving very quickly. So let's say you get to the edge of the platform. Oh no! Well, I still went off the edge, but you kind of get the idea. I'm not focusing on the design here, actually. I can't really, off the top of my head, say if games have a higher deceleration value than an acceleration or the other way around. I wonder what that looks like. We set our deceleration to 10 and our acceleration to 100. Oh my goodness. Well, maybe not to 100. Let's set our deceleration value to 5 then, and our acceleration to 10. I imagine this is not what you want, because it means that once you're at a top speed, once you go fast, you can't stop going. Ah, no, it's like you're on ice skates. You want to go fast. You also want control. So yes. So if I move, I stop moving. It takes me longer to stop moving entirely. Anyway, I'll put this back to 20 for now. What else might we want, as well as different acceleration rates depending on if we're moving or not? Well, one of the things that's going to be useful for us once we add jumping into the game is a different acceleration rate depending on whether we are turning, which is to say that if we're moving to the right and then we suddenly decide, actually, we're going to move to the left, while we're jumping in the air, quite often that's hard to do. So you don't have that kind of fine control maybe in some games where you're like, once you start jumping and you try to turn midair, it's like, you're stuck. You have to keep moving to the right or you have to keep moving to the left. So we're going to go ahead and add that for even while we're on the ground, and then it will also be useful once we start adding jumping into the game as well. So how do we work out if we're trying to change direction? Well, if we're trying to change direction, that means we are trying to move in a direction. So we're going to have a nested if statement in here. And what is it that we're going to ask? Well, we're going to do mathf.sign here. So the sign of something is basically just, if you imagine, a plus or an equal sign. So which is to say, is it a positive value or is it a negative value? So we're going to take our desired velocity, or we could take our input, either one. It doesn't really matter, I don't think. So we could take our input velocity, which is to say the way we want to go. We could say, we want to go in a particular direction, either left or right, right? So it's a sign. If it's a positive value, it will be, say, 1. If it's a negative value, it's -1. I'm pretty sure that's how this works. And we're going to compare it and say, is it not equal to our mathf.sign of something else, which is our current actual movement. So how do we get our current actual movement? Well, we can just go ahead and grab the velocity of our body.use like this, and we'll grab the x value of it, which is to say our moving left and right velocity. So basically what this is saying is, are we trying to move left or right? And is that the same as what we're currently doing, which is left or right? So if we're currently moving to the left, but we're trying to move to the right, I'm going to say that counts as trying to turn. And if we're moving to the left and we're trying to move to the left, then we're not turning. So we're just, doing the same thing we were doing before. So if these aren't the same, that means we're going to turn. We're going to need a new acceleration. We'll call this max turn speed. And we'll go ahead and make a new one of these for our turn speed. So turn speed times, oops, let's not get rid of that, but let's copy it over here. Max speed change is equal to max turn speed multiplied by delta time. And we'll do a little else here for what we would do normally. So now we've got our 3 different acceleration values for whether we are simply moving and trying to go faster and faster, if we've stopped moving and we're trying to decelerate, or if we're turning and trying to go a different direction than we currently are going in. Let's try changing this max turn speed to a really high value. This will allow us to very quickly turn and change to the direction we're moving in. But the moment we start moving in the direction that we were moving in before, we're going to start using our acceleration value again instead. Okay, maybe let's not set it to quite such a high value. That's a bit silly. Let's try setting it just to 30. Again, don't really know what these values actually should be. You can mess around with them yourself, and we can try and work out as well just from watching that video and checking out this ToolKit example, what those values might be like. And we'll really start tweaking those values once we add in jumping and stuff like that. So this has been part 1 of this video. Hopefully this has not just been about implementing these features, but also about understanding how we can have velocity changing, not just as a simple one-to-one basis of I move left on my, I put A on my keyboard, so then I should move left. But there's more subtlety to it. And those subtleties are quite often what makes games feel sort of like clunky and unresponsive. You've all played maybe those indie games where you just feel like the platforming doesn't feel right. And then you play this other game and you're like, oh yeah, the platforming feels really good. So hopefully, fingers crossed, we can get a platforming that feels good, and we can extend as well if we so wish.